All right, good morning. This is Tuesday, February 15th for KAP. We're talking about one last property, but let's do a quick review of our properties that we've already looked at yesterday. We talked about 4. What was those 4 properties? Rating, what was 1? Identity, Afton. Commutative, Shrieker. Associative, and inverse, okay? Those were 4 properties that we talked about yesterday, each talking about a different thing. Again, you will need to know which property is talking about what, and be able to know what it is when you get an example. But today we're going to talk about one last property called the distributive property. Before we get there, let's just talk about the word distributive. We've heard that probably in the real world outside of the math context. What does distributive mean to y'all? Philip? Passing out, passing around, Shrieker, sharing, giving out, right? Usually evenly giving things out, okay? Miss Lytle distributes candy sometimes, but sometimes, okay? And when I don't distribute it to everyone, do I hear about it?
Yes.
Okay, so that's a very important lesson for today. All righty. Okay. So first going over last night's homework, were there any questions that I needed to explain? Sorry guys, I'm trying to recalibrate my board real quick. Oh, thank you.
Did you hear my score?
We'll see.
We beat the high score.
Any questions on it? Pretty good. I mean, you should be checking this at home and just asking questions. All right, I'm moving on. So we're gonna start with another just brain pop video like from yesterday, and then we'll get into the notes. Let me pause and play one of the video. Voices.
Dear Tim and Molly, what is the distributive property? From Rachel. Well, the distributive property is a rule of math that helps us figure out problems involving multiplication and addition. For instance, we can use the distributive property to figure out how many animals are coming in today. 5 trucks are coming today, and each one is carrying 4 cows and 11 chickens. So that's 5 trucks times 4 cows plus 11 chickens. There are a couple of ways to solve the problem of how many total animals we can expect to get. Remember that we generally work with the parentheses first. It looks like in each truck there are 4 plus 11 is 15. Then we have 5 trucks, so 5 times 15 will get us our answer. So we have 75 animals coming in today. But say you don't have a calculator handy. According to the distributive property, 5 times the quantity of 4 plus 11 is the same thing as 5 times 4 plus 5 times 11. This makes it much easier. 5 times 4 is 20, and 5 times 11 is 55, and 20 plus 55 equals 75. So both methods get us 75 as the answer. We just use the distributive property to figure it out without the calculator. Here's a recap. For any numbers a, b, and c, a times a quantity b plus c is equal to a times b plus a times c. See, if you had used the distributive property, it would have been easier to figure out how many animals were coming today. Then you could have built the fence before they got here.
All righty. Okay, so in elementary school, y'all did like partial products, right? Where it was like a way that y'all could do multiplication was you would do like the number times the 10 value and then the number times the 1 value and then add them up. This is similar, not quite the same, but I related a lot to partial products like from elementary school. Okay, so distributive, but mainly means like giving out. I think of like groups of this and all that kind of stuff. So really good examples come from like if you're going to the movie theater, the most recent 20,000th film of the Marvel comic series, like the same movie copy and pasted and just a different character. And you're going to the movies with your friends, or in that case, like the Marvel and don't go to the Marvel movies. but let's say you're going to the concession, and you know there's all those like different combos that you can get. Do y'all know about them? Okay. Or you go to like some store and there's like a combo deal, like, oh, yes, a box combo or anything like that, okay? We can use those like combos for the distributive. Sorry about that. So using combo deals like at the movie theater is great examples of the distributive property. So, for example, like if I went up to the counter and I said, I'd like to buy 2 number 1s, okay? The guy at the cash register is going to be like, oh, you know what the number 1. He's going to look back at the menu, and this is what he's going to see. He's going to see, in the number 1, there is 1 popcorn with 2 drinks. But I don't just want 1 number 1, I want 2 number 1. So what I'm going to do is I'm basically going to like copy and paste that. I'm going to get another popcorn and another 2 drinks, right? In total, what should I get? When I walk away from the counter, in total, I should have 4 drinks and 2 popcorn. Okay, I'm going to go in the order that we have. So 2 popcorn plus 4 drinks. Correct? Do y'all agree with that? Talking about math, would I add those 2 numbers together? No. Am I going to be pouring my popcorn into my Coca-Cola? No. Okay, you want to keep those 2 things separate. Okay, when we go into the math things, we're going to be talking about different types of terms where it's just numbers and when it has variables. Those are things you cannot add because of order of operations. Okay, so that's looking at the pictures. Let's look at the math behind it. Okay, again, it's saying I want 2 combos or 2 combo of the number 1s. In the parentheses is what's included in just 1 number 1. Okay, 1 popcorn and 2 drinks. Do y'all agree with that statement? Okay, looking at the math of it, if I have 1P plus 2D, I cannot add those things because they are unlike terms. Popcorn and drinks, I cannot say, oh, that's 3. No, it's 1 popcorn and 2 drinks. They are separate things. Now, with the distributive property, I can sort of work around the order of operations. Again, order of operations tells me I should be doing grouping first, but this is an equivalent expression. This is a way to sort of work around it. With this 2 on the outside, what operation is happening? Multiplication. And so a way to work around it is I'm going to distribute. I'm going to give out that 2 to the 1 and to the 2. Okay? I'm going to multiply those terms. Again, a little bit of a cleaner one is over here. I'm going to distribute that 2 to both terms. Again, that 2 is multiplying, so I'm going to do 2 times the 1 popcorn. 2 times 1 would give me 2 popcorn. And then 2 times the 2 drinks, 2 times 2 would give me 4 drinks. Does that match my model? Yes. Again, I can't take it one step further because those 2 items are not similar. I cannot add them as they are. In total, I should have 2 popcorns and 4 drinks. Okay? Let's do one more, and then I'll let you do the last one together, or on your own. I'd like to buy 3 number 2s. Well, I don't even know what's in a number 2. That's a number 2. What do y'all see? I have 2 popcorn and 3 M&Ms. Okay? I'd like to buy 3 combos of 2 popcorn and 3 M&Ms. Okay? I'm going to draw out my model. That's 1. I'm going to copy and paste it twice. Okay? Here's another popcorn and another popcorn and then another. That's 2, and I need another one. So you're writing this on your page. Pause and play. Okay. In total, I should have how many popcorns? 6 popcorn plus 9 M&Ms. If Miss Idle doesn't get her 9 boxes of M&Ms, do you think I'm gonna get mad? Yes. Okay. If y'all don't give me my group, I'm gonna. You know how they turn into a Karen? I'm gonna turn into a Karen. I'm gonna be real mad. Okay. I want my 9 M&Ms. Because so this is like one of the biggest math mistakes that kids make is that they only distribute to the first term. Okay, so drawing these arrows is it's a quick 2-second reminder to do it to both of the terms. And again, when I distribute, what operation should we be thinking about? Multiplication. Okay, I'm sort of going to skip this one because that's just rewriting and drawing the arrows. I don't think I'll need it as KAP. Okay, but let's go ahead and distribute. 3 times the 2P gives me 6p, and then 3 times the 3m gives me 9m. In total, I should have 6 popcorns and 9 M&Ms. Okay? If I don't distribute the candy, y'all, I hear about it. If y'all don't distribute the numbers, the math, y'all will hear about it. Yes, sir. So, will we add those variables? The answer is no, because those are unlike terms. We'll see it more in math terms without popcorn, without food and stuff like that. We'll talk about what it means to be like terms and unlike terms. Because they're two different variables, I cannot add those things. Okay, because technically, like, there would probably be some like multiplication happening between the 6 and the 2. Like if we're talking about the cost, you would first have to do 6 times the cost and all that stuff. Okay, go ahead and do the last one on your own. Pause and play when you're ready to check. Ready to go? All right. And each combo, I'm buying 2 number 3s, and the number 3 has 3 drinks plus 2 M. Okay, let's distribute. I should in total have
6 drinks and 4
M&Ms. Okay, very good. Now, sadly, I know we're so sad, especially right before lunch. We're going to stop talking about food. Okay, just focus on the math. There are algebra tiles that you can use on like the little sticky things, but I know we're going to get to modeling. There's a Brady Camp. You know what Brady Camp is?
No.
Okay, it's a little app online where it has like the math manipulatives at home. Okay, we used it a lot last year with online stuff, but we'll just keep going. Again, to distribute means to give out, usually give out evenly, but it also means to multiply. When using distributive property, we multiply the number on the outside of the parentheses to each term on the inside. Okay? We use the distributive property to find equivalent expressions. Again, this is another one of the properties that we talked about yesterday. It's another equivalent way to write those things. It's another 5 plus 2 is 2 plus 5. It's the same thing. Writing it with the term on the outside is the same thing if you distribute it. Okay? Distributive we specifically use when we need to multiply a group of terms. It will have some numbers, but a group of terms being added or subtracted. So again, if you ever see like a number right outside two things, like on this first example, whenever you see something like this, it's probably going to go off in your head that you need to distribute. Okay? So, looking at that, again, this is more of a math example where you won't see popcorns or M&Ms. Order of operations, again, tells me that I should be doing my grouping first. But in this, I have one thing that has just the 5, nothing with it, and then that 3x. That x is a variable, and with the 3 and the x, what operation is going on with those two things? Multiplication. But do I know the value of x as a thing on the paper? No. So I can't actually solve this problem. So again, this is when I use the distributive property. I can't do the grouping first, but what I can do is I can distribute, and it doesn't solve the problem, it's just an equivalent way to write it. Okay? So again, the word for this, it's saying, the way I like to think of it is 2 groups of 5 plus 3x. 2 groups of 5 plus 3x's. I'm going to show you how you would model with algebra tiles. Okay, first I'm going to start with the groups. I'm going to look at one group of 5 plus 3x. With our algebra tiles, we have little sticks and little, squares and sticks. The squares usually mean, I can't say it. The sticks, I would say that's a stick, is usually an X, and then the little squares just represent 1. Again, they're different because we don't know what X is, but we do know what 1 means. Okay? So, in this 5 plus 3x, to show 5, I'm going to do 1, 2, 3, 4, 5. You can put 1 in it, you don't need to. And then 3 x's. Those I am going to label because they sort of flip it. 3 x's. Sorry. Do y'all agree that's 5 and then 3 x's? Again, I cannot say that they are the same thing because x could mean 4, it could mean 4,000, it could mean 2. Okay, so we have to leave that as x, and then those are the other ones. We cannot combine them. We call them unlike terms. That is one group, but I need 2 groups of it, so I'm going to copy and paste it. 1, 2, 3, 4, 5, 1, 2, 3. Try my best. And then count up the total. In total, I have how many of these little squares? I have 10 total, plus how many of those x's? 6x. Again, I can't take it any further because I still don't know the value of x, but this is equivalent. It's representing the same thing. He's that same thing. Oh, yeah. Okay? Of course, we're not going to make you model every single one. Although, if you do, like, make me mad one day, maybe I will, because I love how much y'all love models. My favorite. Okay? So we're going to focus more on the math. Again, when I distribute, it means to do an operation, multiply. So this middle step, I'll just do a few times, but I don't expect y'all to do it every time. I'm going to do 2 times 5 plus 2 times that 3x. Okay, let's actually go ahead and solve those. 2 times 5 gives me 10, and then 2 times 3x gives me 6x. Okay, again, I know a lot of y'all will do that first step and that last step. That minimum for KAP students, I don't expect y'all to write it. Just know that's what's going on. Okay, there's no more simplifying possible because I cannot add something with a variable to something without a variable. Those are 2 different types of things. That's like my popcorn and my focus solo. Don't combine them. It's nasty. It's against the law, Brayden. Well, that, I know. So that's why I'm focused. That's actually really good because it's salty and sweet. But we're focusing on the popcorn and the soda. All right, on this next one, we have what kind of number? Negative or a subtraction. Okay? So the words for this, it would be, take a guess.
3 groups of 4 minus x.
3 groups of x minus 4. Because the order of subtraction matters. We talked about that yesterday. I can't do 4 minus x. It's not the same thing as x minus 4. We're going to keep it in the same order. Okay, so x minus 4. Okay? If we first talking about the groups, x minus 4 is in one group. I'm going to have an x. And then if we remember the models from the beginning of the year, positives are just like those blank squares, and negative, I would put a little negative sign in. Sometimes they shade it in. It just depends on the problem. It will usually have a key, though. They'll say, oh, the shaded one means negative, or one a negative, means negative. Yes, sir? It's the same thing, because x minus 4 is the same thing if you keep and add the opposite. Right? We've talked about that.
That's so cool.
It is so cool. Okay? That's one group. How many groups do I need of that? 3 groups. So copy and paste. Yes, you do.
Yes.
Again, if I'm finishing before you, maybe complain less and do more. Ooh. Okay, thank you for working.
Yes.
All right, let's see. What do we have in total? How many x's do I have? 3x. And then there's 2 ways I could write this. I could say 3x minus 12, right? Because there's 12 minus 12. Or I could say 3x plus negative 12. Those are the same thing. It means the same thing. They're equivalent. Okay? Technically, the more correct one is that first one. It's more simplified because I had to write that. But I would accept either one. As y'all go up, especially as KAP students, as y'all go up in math, this will be the only acceptable one. I know that like when I was in high school, they would say awkward if I didn't tie it, or like 1 or 2 points. I'm just making y'all aware, okay? But they are the same thing. Again, looking at the math side of it, Ms. Idle has mentioned this many a time. Writing it as adding the opposite instead of subtraction is a helpful thing to do. Okay, so 3x minus 4 is the same thing as 3 groups of x plus negative 4. They're the same thing. It's really up to preference. So now I'm going to distribute from this. I'm copying this one, x plus negative 4, and then distributing from there. To distribute means to give out, and it means to do what operation? Multiply. So I'm going to do 3 times the x plus 3 times the negative 4. Simplifying that down, 3 times x is 3x. Plus 3 times negative 4 is negative 12. Again, I can simplify that. Anytime you see you're adding a negative, that's the same thing as just plain old Jane subtraction. Same thing. Okay? Just practicing rewriting real quick. We don't have to model this next one, just rewriting. I see that it's adding a negative. It's the same thing as 4x minus 10. Okay? I see that it's adding a negative. That's the same thing as negative 4x minus 10. Very good. Whenever you see adding an opposite, adding a negative, it's the same thing as subtraction. Okay? Hopefully I've said that 6,000 times enough. Maybe 6 once. Okay? I want y'all to practice on these. Again, this middle step is this one up here where like they wrote it out as captions. I don't mind if y'all do or don't do that. It's up to y'all. But I do want that last step. On number 2, it's still distributive. It's just on the other side. On number 3, again, they're rewriting, then distributing, then solving, and then simplifying. It's a little extra. Okay? Go ahead and try these out. I'll give y'all a minute, and then we'll go over them. All right, this first one, y'all tell me what did you get? 6 times x and 6 times 5 gives me
6 minus.
Okay, one more time. What did we get?
6x plus 30.
Thank you. Okay. On this next one, again, that's 7. It's just on the other side. We still want to work left to right. Technically, because it's addition, it doesn't matter what order you do it in, but let's just keep it in order. This one would give me, if I distributed, plus 70. Very good. Okay, this next one, I will fill in all of the blanks just to show you what it wanted. 2 groups of r minus 4 is the same thing as 2 groups of r plus negative 4. That's what it wanted on that first one. And then distributing. Again, I'm going to skip this step because I really don't need captured. I don't think I'll need it. 2 times r gives me 2r plus 2 times negative 4 is negative 8. But we know that adding a negative is the same thing as subtracting 8. That is the final, most beautiful form of that. Okay? Again, if you have this one, it's technically correct, but get into the habit of the right subtraction. Last one. Negative 12x plus negative 32. That would be 32. 4 times 8 is 32. Okay. And negative 12x minus 32. Now, I'm going to take a pause and I'm going to show y'all another way to do it. That is just as fine. It's just a little different. But I just want y'all to have more than one option for these. I'm going to redo 3 and 4 in a different way. So 2 groups of r minus 4, and then negative 4 groups of 3x plus 8. Now, what you can also do, instead of rewriting, this is another way to do it without rewriting, is I break up the terms. I break up the variables with the numbers, and I circle the term with the sign in front. Does this r have anything in front of it? No. Okay, so it's going to look, no, it doesn't have anything in front of it. So this is going to look a little weird, but I'm circling it with that term, with the sign in front. That 4 has that minus. But remember, we can also think of that as a sort of negative 4 from up here. Okay, what I then can do is distribute like I did. Again, stay with me because you might like this version better. 2 times r gives me 2r, and then 2 times negative 4 gives me negative 8. And that's already rewritten. I didn't have to simplify or return it. Do you see how I did that? Okay, let me do it one more time. Again, within the parentheses, I'm going to circle the term with the sign in front. the term with the sign in front, and then distribute. Negative 4 times negative 3x, or sorry, negative 4 times positive 3x gives me
negative
negative 12x, negative 4 times the positive 8, negative 32. I don't have to rewrite, I'm just writing the sign, and that turns into my operation sign. If you like that better, you can. I don't know why we're backing up. I still have to tell you about homework. For homework, it is a maze. We start at the start and we finish at the finish. For this problem right here, these two right here, both of them have a negative sign on the outside of the parentheses, which I don't think we've seen before, so I wanted to talk about it. When it says negative x plus 9, we need to distribute that negative. But what number could I put with that negative and not change the value of it? 1. Okay? If it helps you out, it's sort of weird to just distribute a negative. So you can make it a negative 1. Negative times that positive would be a negative x. Negative 1 times positive 9, negative 9. Just to help you out. Don't forget to study for your quiz on Thursday.